So let's do some examples, and you're going to write all of this in your math notebook. Use your grid lines. Hopefully you have graph paper in your notebook. It'll be very helpful when you are doing all of these examples. So the first system we're going to do is 2x, oh, hold on. Plus y equals 2. And then negative x plus y equals 5. So remember, there's a lot of ways we can graph. We can find the x-intercept by plugging in 0 for y, and then find the y-intercept, and we can graph those 2 points and connect them. Or we can rearrange this to slope-intercept form. And because I really want you getting, fluent with that, I'm gonna do that. I'm gonna rearrange this into slope-intercept. So I'm going to subtract 2y from both sides. So we'll have y equals negative, not 2y, 2x. Y equals negative 2x plus 2. And now it's in slope-intercept form because the y was almost already isolated. So I know that I'm crossing the y-axis at positive 2. So I'm going to do some lines here. Again, you have a graph notebook, the lines are already there, so you can graph really, really nicely and precisely. Okay, so we're gonna do pink. So it's gonna cross here at positive 2, and then the slope is negative 2. So I'm going down 2 over 1. And I really only need 2 points, but you could go make 3, at least. And then you're going to want a ruler or a nice straight edge to connect your line and make it as long as possible. Remember, don't just connect the 3 or however many points that you have. Make it a stretch across the graph. So here's our first line. Okay, so we've just graphed 2x plus y equals 2. Now, if you're thinking about doing this by graphing from standard form and finding the x and y intercept, you would plug in a 0 for y, you would divide both sides by 2, and your x-intercept would be 1. And you can see it right there at 1. And then if you were plugging in a 0 for x, that would be 0, and so y would equal 2, which means the y-intercept would be 2, and you can see that there. So no matter how you choose to do it, you should be graphing the same line. So now let's look at this one. We could graph it with the x-intercepts and the y-intercept, or we can solve for y. I'm going to do that again. So here, all I need to do is add x to both sides. So I get y, oops, I didn't want that to be black, pink, oh well. Y equals x plus 5, right? Because I just added x to both sides. So y-intercept, let's do this a different color, is 5. 1, 2, 3, 4, 5. And the slope is positive 1 because there's no, if there's no coefficient in front of x, that means that the slope is 1. So I'm going up 1 over 1, which also means I'm going down 1 and left 1. Down 1, left 1. And so this is the line that's forming. And so that's an up 1 over 1 slope. I'm going to connect them the best I can here without any lines. This is pretty tricky. Something like that. It's not perfect, but you can see which point they intersect at, okay? So that means that our solution, the x and y value that makes both of these true, is -1 and 4. -1 and 4. Now, what we want to do is we want to check our answer. Okay, this is super important. So we need to check. we're going to substitute in our solution to each equation and solve it. At this point, it doesn't matter which equation you use. You can use the slope-intercept form, or you can use the standard form. I'll use, I don't know, I guess I'll use slope-intercept. So y is 4. So 4 equals -2 times x. X is -1. And then plus 2. 4 equals -2 times -1 is 2, plus 2 is 4. So that works. Let's check the other one. 4 equals, remember, you got to use the same point here because it's a solution to both. -1 plus 5. Yeah, 4 equals, this is 5 minus 1, same thing, so you get 4. And it works. Okay, let's do another one. So on this one, we're going to use a real world scenario. Okay, so a business rents inline skates for $15 per day and bicycles for $30 per day. So we know, let's see, think standard, 15x for inline skates, or what did it say? Yeah, and bicycles for 30, and 30 for bicycles. Okay. On a certain day, they make 25 rentals for total sales of 450. Okay, so they rent $15 per inline, $30 per bike, and the total is 450. That's the same as a certain day they make 25 rentals. 25 rentals. So the number of rentals, this is the number of inline skates, the number of, so the total number of rentals would be the X, the number of rentals for skates, number of rentals for bikes is 25. Okay, so on a certain day when they sell 25, we don't know how many of each that is, but that's how many sales it is. And when we're talking money, we're talking 15 times the number of sales, 30 times the number of sales for that one, and it equals 450. So this is how we write a system showing both scenarios. And over here, I'm just going to take note that X is the number of skates that they rented, and Y is the number of bikes they rented. Okay, so two different things happening. One is totaling the money, one is totaling the amount of rentals, but we still don't know X and Y, and we know they're going to be the same because when they rented 25, they earned 450. So that's why the solution is going to be for both equations for X and Y. So let's, I'm gonna keep rewriting these as slope-intercept. So if I subtract 15x from both sides, I get 30y equals -15x plus 450. And I divide everything by 30. And I get y equals -1/2x. Plus, this is I can't do math, it's early this morning. Let's see. $150, I believe. I think that's right. Okay, so okay, wait, I have an extra 0 there, so let me get rid of that. Okay, it's 15. Okay, so this is our slope-intercept equation for the first one, and then this one's really easy. We're just subtracting x, right? So our next slope-intercept is going to be y equals -x plus 25. So let's graph these. I'm going to make some marks here on my graph, trying to be as precise as possible. Typically, you would use about 5 lines. I'm just kind of winging it here, but try to make them as spaced out as evenly as possible. So let's change the color. This time we'll use purple. Since I've got bigger numbers here and I don't want to make all those tick marks, I'm just going to say that I'm going to go up by 5s. So each one of these is a unit of 5. So I need my y-intercept to be at 15, 5, 10, 15. And from there, I'm doing a negative, I'm going down 1 over 2, right? Well, it's okay since you're scaled at 5s. If you keep it scaled when you go down 1 over 2, it'll still show the proper slope. So I'm going to go down 1 over 2, down 1 over 2, and I get a line something like that. So I'm going to get a straight edge, straight ruler. I'm going to connect them. Not perfectly straight, but good enough for now, okay? Change the color, and we're going to graph this one. So we have a y-intercept at 25. So 5, 10, 15, 20, 25. Whoops, didn't mean to do that. Oh, that's nice. I moved my line. Let's go back to this one. Okay, 25. By the way, guys, a nice trick is the bigger you make your dots when you are plotting on your graph, the nicer it's going to turn out when you go to connect them. Just a good rule of thumb. And then from there, it's -1. So I'm going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Wait a minute, this isn't looking too good. Down 1 over 1. Yeah, I didn't, hold on. See, this no line thing is messing me up. Okay, that one's right. Down 1 over 1 should be more like this. Then down 1 over 1. Check this, hold on. Okay, so I checked these in Desmos and it says it's going to cross right here, and you guys probably saw that on yours because you have the grid lines and you were able to graph it properly. It just means that my angle here wasn't quite right. So the point here, remember, we were counting by 5s, okay? So we don't want to say that the value is 4 and 1. We want to say that it is 20 and 5, okay? So you got to remember, so it's going to be helpful for you if you label. I didn't want to mess up, you know, put it too cluttered on my graph, so I didn't label it, but just make sure you keep your units, okay, in check, because the value of it should be 20 and 5, not 4 and 1. Okay, so then we're going to check our answer. So we have y equals 5, so 5 equals, and ooh, you know what'd be really nice when we get to this one is use that one, but I'm gonna use this one for now. We gotta keep working with our fractions, it's good practice. -half of 20, and then plus 15. So 5 equals, half of 20 is 10, negative times a positive is negative. And there we go, 5 equals 5, works out. This next one, look at how nice this one is. You literally just put those values in. So you're gonna do x is 20, y is 5, and you look and go, whoops, what happened? Hold on, guys, hold on. Issues, okay. And it equals 25. I use this one right here, super simple. So you got options, you got 4 options when you're going to plug these in and check, okay? Use whatever's gonna be faster and make sense. So this is the process for graphing from equations and things like that. Now, And then checking your answers and seeing the solution of your intersection point. Again, this one should have been right here. Remember, guys, you also have the option of doing an X and Y table each time you go to graph. And if that is more comfortable for you, then go ahead and do that. And you have your function, right? These are your functions. These are your equations, your systems. They're all the same thing. And you would just start picking some values for X and apply it. You'd actually need it to be in this form so you could get your output isolated. But you could just, after you put it in slope-intercept form, you could go, okay, I'm going to pick, typically what people pick are -1, 0, and 1. Okay, now you should do 5, but 3 is okay. And then you just apply the function. So you would go, okay, -1 times -2 is 2, plus 2 is 4. Okay, and then you would do it again and do it again. And then you would graph those points and connect them. Lots and lots of ways to keep connecting our equations, how to make X and Y value tables, graphs, and then being able to check it with substitution. So let's keep focusing on all of those things and making sense of it. Have fun, guys. Happy learning.